It's going down like a staircase, and so we have different levels of erosion that would be differential erosion.
And a fault where you can see the layering.
You see some things look like they're broken. Now we're looking obliquely at this, so we're looking at a rather interesting fracture suite here that is the result of the monoclinal flexion in the system. You can see these vertical lines are these beautiful fractures in this system, and it also, and it may be difficult to see, this is sort of a zone that comes out a little bit, then it steps back. Goes out a little bit, steps back. And so we're going step, 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 step along an eroded wall. So we're looking at a suite of fractures like this that are controlling the way the outcrop looks. We're looking at different layers, different levels of competence, because we're getting down into the Hermit Shale and below. This is in the Kaibab to the Toroweap, more resistant. So they show the fractures a little bit better in that particular system. But a beautiful example of fractures related to the monoclinal flexion in this system. And when we're taking this picture, by the way, that fault we described earlier, we're standing on it. Just put our right foot right on that fault plane when we took that particular photo. Okay? Now, this is this summer. Just not even a week and a half ago. Do you see anything?
Incline.
See an active
I heard.
Incline.
Not pointed out.
Anticline fold.
So we have a little anticlinal fold. This is in the Paleoproterozoic, and they give this a beautiful name, just rolls off the tongue, XB. Paleoproterozoic XB. You see this beautiful anticline in here. Now, I'm going to ask you a question. Did this form under extremely high temperature or at relatively lower temperatures? Tough call. John?
I would say it had to form under high temperatures because the higher temperature would make materials flex more. If they'd been low temperatures, they would have broken.
How do we test that?
I would ask you.
Well, let's just examine the fold. Let's ask it some questions. When you get into the field, you start asking rocks questions. So first you introduce yourself. Hello, my name's Brian. Can you tell me your story? What happened? When you look at it, notice down here, it's relatively sharp. As we go up, what happens?
Less and less sharp.
It actually gets less sharp as we go up. If we go over here, and this is going to be kind of a challenge, which way are the rocks dipping right there? They're dipping this way, exactly. So this thing right through here it's an F word. It's a fault. Localizing this little bitty fold, and the material is competent enough that we're seeing again flexural slip, which suggests it may have been folded at a little bit lower temperatures. This is actually a laramide event here in the older rock, cutting across, causing it to modify just slightly within that particular system.
So Dr. Tapp,
Yeah.
using that same picture, how would it have looked if it had folded at higher temperature?
You would preserve that same basic, I didn't put a picture in, but you would have the same basic geometry throughout.
Oh, okay.
okay? I can show that next time. Now, what do you see here other than this lovely waterfall and my wife, that's Gail, and she's pointing something out. What is she pointing out? It's an F word. Let's be confident instead of saying, say it loudly. Fractures. See these? These are beautiful Griffith type sheet fractures. And so this is my wife up here yelling at me over the den of the waterfall going, I think these are Griffith type sheet fractures. Beautiful unroofing fractures. Here. Gorgeous.
So Griffith type of horizontal.
Well, these are just unloading.
Oh.
Unloading related sheet fractures associated with the unroofing of this, the erosion, and just the expansion of the granite. This is the Longs Peak granite here in its 2 mica phase here. Okay? So you find structures everywhere. Extraordinary. What's happening here? This again, Stills 2015. This is the old Fall River Road. It's a gravel road that goes all the way up to the top. Yeah, is loudly and with confidence. It's tilted. We have, there's an F word right there. So we have a fold there and it comes back. Here you've got this pod of granite here. Look, this comes in and goes around it. So we have to ask ourselves, what's going on? Is this material cold or warm during formation? Is that granite forming as an anatectic phase during the folding process, during the high temperature phase of the metamorphism and deformation of the XB during the Yavapai accretion, which of course we all know what it is. But we're looking at, we have to add a little bit, get a little bit more information. So if we look closely at a different part of the system, you see the fold here. There is a pod right there of anatectic granite. It's in the form of a sigma grain, a large sigma grain. So this occurred during the high temperature events. So we have high temperature events, we have low temperature events in this particular system. Now we're at Glacier National Park here, Logan Pass. Anything happening? Yeah. We've got a fault right there. We've got these interesting fractures in this particular system on the edge of our glacial valley. What is it? It's a rock! What, did anything happen here? This is Mount Kidd. This is in the Kananaskis Range, Alberta. We are south and west of Calgary. We're in the Canadian Cordillera. Do you see anything? I see trees. I see blue sky.
Don't you have a big anticline? Top there for the big one?
Okay, so what's that?
That's the
Well, is there more than one?
Yeah,
Yes.
it's like, it goes,
Yes.
like,
Because
there's a little
it's
edge.
pretty tight down here, and then it kind of goes whoop, whoop, whoop.
Yeah.
There, then we have this lovely thing. How big is it?
It's pretty large.
Very large.
Yeah, these trees here, those trees are on average about 9 meters. So it's big.
Don't you have a fault right there also, sir?
We've got a fault right here, in there. There's some small scale faulting superimposed throughout. This is at the tip line of the imbricate fan of the Canadian Cordillera. And it's a beautiful flexural slip fault in that particular system. And we've got kids needing to come in to learn physical chemistry. I wish them well. Yeah.
One thing that I noticed you did cover on your syllabus